Chapter 8, Estimation. So in hypothesis tests, the purpose was to make a decision about a population parameter. In terms of it being greater than, less than, or not equal to some claimed value. But what if you want to actually know what the value of the parameter is? So remember, in hypothesis testing, we always start assuming the null hypothesis is true, which means at the end we can never prove it's true. So at the end we can't say we have significant evidence that mu is 2. We can only say there's not evidence that it differs from 2 or is less than 2 or greater than 2. So in this case you would need to do estimation. And there are two types of estimation. The first one is a point estimate. Point estimates, which is exactly like it sounds. So this is an estimate that will be a single point on the number line, so a single number. And then an interval estimate and interval estimates will be like they sound. They will be an interval of values that we will claim that we have. We think there's some level of confidence that the population parameter is in that interval. And so those are also then known as confidence intervals. And that's going to be our main focus for this chapter. So starting with the first word that was up here with a point estimate. So a point estimate is going to just be a single number computed from sample data to estimate a corresponding population parameter. Okay, so it's a single number, which is why it's called a point estimate. It's going to be a single point on the number line, and it's computed from sample data, but we're going to use it to estimate the corresponding population parameter. So again, taking something computed from sample data and using it as an educated guess about something about the population. So doing inferential statistics. So a point estimate is just the statistic that you've actually calculated in previous chapters. So when we have qualitative data, we are going to use p hat as our point estimate for p. And when we have quantitative data, we're going to use x bar as our point estimate for mu. Okay. So in Unit 1, we were introduced to x bar and p hat as statistics because they're a single number computed from sample data, so they meet the definition of a statistic. And now we're just giving them another name, a point estimate, because not only are they a single number computed from sample data, but now we're going to use them to estimate a population parameter. Now, larger samples tend to give us a better point estimate since the distribution of possible values of the random variable is less spread out for larger sample sizes. But it would be rare for our sample result to match the population parameter value perfectly. So instead of looking at a single number, this point estimate, we're going to look at an entire interval of plausible values for the parameter called an interval estimate or a confidence interval. So this is going to be an interval of numbers around the point estimate that we will have a certain level, and we'll see where those levels come from in a second here. I have a certain level of confidence contains the true value of the population parameter. So now in general, a confidence interval, when we're using these symmetric distributions, so right now as we're looking at normal and t distributions, those are both symmetric bell-shaped curve distributions. So in that case, our confidence interval is going to be this point estimate, give or take some margin of error. Okay, so we're going to start with some point estimate and add this margin of error, start with that point estimate and subtract some margin of error, and that's going to give us these two endpoints here for our interval estimate. Okay, so we're going to have, either p hat, give or take some margin of error, or we're going to have x bar, give or take some margin of error on these initial ones that we're going to look at.